Hey, what's going on, guys? Let's do this problem right here. The question is asking transverse sinusoidal wave is traveling in the plus x direction with v is equal to 80 meter per second at t is equal to 0. A particle at x is equal to 0 is at rest and is displaced by 4 centimeter, and they have given maximum transverse speed of the particle is 16 meter per second. So the first question is asking find the frequency. Let's see how we can find it. So since we have this information, maximum speed, we know the formula for maximum speed, that is, I'm doing the A part. So V max is equal to A omega, right? And we know the amplitude and we know V max. If I find out omega, I can find the frequency because omega is equal to 2 pi f. It's easy to find the frequency. So let's find the omega first. So V max is 16. Amplitude that is provided, that is at rest, is displaced by 4 centimeters. That means this is the amplitude. So that is equal to 0. So we can state right here 0.04 is our amplitude. So here we are going to have 16 equal to 0.04 omega. Therefore omega is going to be equal to 16 over 0.04. That's going to be equal to 400, right? 400 radians per second. And from this one I can find the f, because omega is equal to 2 pi f. F is going to be equal to omega over 2 pi, and here we have omega 400 radians per second divided by 2 pi. That's going to give us 63.66 hertz. So this is the answer for the first question. So let's do the second question, that is asking for the lambda. So we know that lambda is equal to 2 pi over k. We don't have the k right here. So let's use another equation. V is equal to f lambda. That will work. So V is equal to f lambda. Lambda is equal to V over f. And we have the V that is provided 80 meter per second. 80 meter per second divided by frequency, that is frequency we found out that is 63.66 hertz. And then from this one I can find the lambda, that comes out to be 1.26 meter. So let's do the C part, that is asking for the amplitude. We know that amplitude is already 0.04. So whenever they say at rest is displaced by this one, and that means that's the amplitude. So here we are going to have the amplitude, that is A is going to be equal to 0.04 meter. And let's do the D part, asking for the K. So here I can use the K is equal to 2 pi over lambda. 2 pi over lambda, that is we found out right here, that's 1.26. And if I calculate this value, this one comes out to be 4.99 radians per meter. So this is our constant. And then E part is asking for the omega. That one we found out right here already. It's right here. That is equal to 400 radians per second. And the F part is asking for the phi. So here they have given the equation, so it's very easy to find the phi, because we know in the initial state x is equal to 0, right? So this one will be cancelled, and t is equal to 0. This one also will be cancelled, and we only left with sine phi. So we can write the equation as y is equal to ym sine phi. And here we have the y distance at 0, it's 4 centimeter. So we can write it as 0.04 meter. And the other side we have the amplitude, that's 0.04 meter. And then we have sine phi. And if you flip this around and if you bring it to the other side, that's going to be sine phi is going to be equal to 1. And this is giving the direct answer, because sine phi is equal to 1 at 90 degree, right? So we can directly say phi is equal to 90 degree. And let's go to the G part. The G part is asking what is the correct sign before the omega. And if you look at this question right here, they have said that a transverse sinusoidal wave is traveling in the plus x direction. So plus x direction means this one is moving to the right side, right? So when we have something move to the right side, we have to put the negative right here. So this value is negative in front of the omega t. So the answer for this one is this one is negative. So the sign before the omega t is going to be negative. And that's how we do these problems. I hope you guys like this video. See you next time.